Hi science students, let's go ahead and break down AKS 7C so we can identify all the important information we need to know about thermal energy. So our AKS says plan and carry out investigations to describe how molecular motion relates to thermal energy in terms of conduction, convection, and radiation. So let's start out by picking out our key terms as we go through our AKS. So I think that plan and carry out investigations is certainly going to be an important science skill we need to be able to do to complete this standard and to master this AKS. So if we're planning and carrying out investigations as scientists, we're going to be using the scientific method to ask, investigate, and answer our own questions. As scientists, we need to be able to identify what the questions are and then be able to develop a plan to answer them. Not only are we carrying out investigations, doing investigations, we're also taking charge and planning those investigations to answer our own questions. Our next important key terms in this standard are going to be molecular motion. So we need to be able to describe this molecular motion, and in order to do so, we need to know what that means. So molecular motion, and I'm going to write it up here and I'll draw an arrow. Molecular motion is going to be movements of molecules due to the temperature being applied. So I'm going to give you some examples of that. So I know that molecules, for example, if we're talking about molecules of water, molecules are going to increase their motion and increase their energy, their kinetic energy. They're going to start moving around more if I'm increasing the temperature. So if I want to draw this as an example, I'm going to put a little arrow to show that I'm increasing. If I increase temperature, I am also going to increase the kinetic energy of the molecules. And I'm going to use H2O as my example. So as I increase the temperature, I turn up the heat, I should expect to see that those molecules are moving around faster, they're beginning to break bonds from one another as they move quickly to move apart from each other. If I decrease the temperature, I go the opposite direction. I should expect to see a decrease in kinetic energy. I should see that the molecules are slowing down in motion, typically moving closer together, beginning to solidify together as they slow down in temperature. I'm going to draw an arrow from molecular motion up to this information, just like that. All right. And I'm going to go on in my standard. So far I'm planning and carrying out an investigation to describe molecular motion. The next important terms that I'm going to mark on here are going to be thermal energy. So thermal energy is the focus of this standard. That's the key takeaway. And thermal energy is going to also be known as heat energy. So I'm going to write AKA heat energy, just to remind myself that it may also be called that. So thermal energy is going to show a rise in temperature causing the atoms to move faster, they begin to collide with one another. So thermal energy is going to have to do with those collisions due to temperature change. So I'm going to draw an arrow like this, and I'm going to write a rise in temperature causes atoms to move faster and collide with one another. They bump into one another the faster that they're moving. So lastly, these three terms, my three versions or options for energy exchange: conduction, convection, and radiation. I'm going to put some purple boxes around them. All three of these are going to be my options for energy exchange. So I want to draw a line connecting all of them, and I'm going to write energy exchange, because these are the three ways that thermal energy can be exchanged: through conduction, through convection, or through radiation, depending on the scenario. So let's talk about conduction first. I'm going to draw a little picture of a pot on the stove. I want you to draw that as well. So here's my little pot on the stove. I'm going to draw the stove eye beneath it. And I'm just doing this with some little rings to show my little stove eye turned on. And so conduction is going to take place. Energy will exchange because the two items are physically touching one another. So thermal energy is being transferred from the eye into the pot because they are physically touching. So the two objects physically touch. Convection is going to be a different form of energy exchange. And for this one, I'm going to draw an aquarium with a few little goldfish in it. So this is going to be my aquarium. Here's one of my little goldfish. Here's another one. Let's draw some water across the top so that we know that this is an aquarium. And then I'm going to draw a circle. So I've got a blue arrow pointing down, and then I've got a red arrow going the opposite direction pointing up. So the process of convection works the same with liquids as it does with gases. So cold liquids are going to sink to the bottom, and that's what I've drawn with my little blue arrow, and hot liquids are going to rise to the top. The same goes for gases. So if you've ever been in a multiple-story house, you might have recognized that it's warmer on the top floor than it is in the basement. This is because that gas is rising to the top if it's the hottest and sinking to the bottom if it's cool. So beneath my aquarium, I'm going to write with one star, cold liquids sink to the bottom. And then at the second star, I'm going to write hot liquids rise to the top. So as I see in my aquarium, I can see that the cold liquid is sinking to the bottom, the hot liquid is rising to the top, and they will continue this process of convection until they reach equilibrium, where all molecules of water throughout the aquarium are the same temperature. Our last form of energy exchange is going to be radiation, and I'm going to draw a picture of the sun here, just like that. And then I'm going to draw a little picture of a stick person down here. This little stick person is standing out in the sun, and he can feel the heat rays of the sun beaming down on him. Even though the sun is not touching him, he can feel the warmth of the sun. So radiation is going to be able to warm that person without actually physically touching him. So radiation occurs because these waves of radiant light are moving from the sun to the person. So down here we're going to write warms without touching. Just like that. So if I'm looking back at my standard overall, I know that I'm going to have to plan and carry out some kind of investigation in order to investigate thermal energy. I need to be looking at the motion of those molecules as they are heating up or cooling down, and I have 3 different options of how to look at that energy exchange. I can use conduction, convection, or radiation. I could use a combination of all 3 if I so choose. But in my investigation, my focus should be that thermal energy, that heat energy, and I should be thinking about the motion of the molecules, not just the temperature of them. That's everything I have for you today. Have a really great day. Bye-bye.